The next ones. Again, trying to get across that complex fractions are really just division problems. This means that I'm going to take this top fraction divided by this bottom fraction. And when we divide fractions, what do we have to do? Flip it. I'm going to flip the bottom one. So I'm going to rewrite this. 15s to the 4th over 3t to the 5th u to the 3rd times the reciprocal of the bottom one. So 9t squared u over 5rs squared. Now it looks like those problems we were doing earlier, right? Just a little longer. I like to reduce my numbers, my coefficients first. 5 goes into 5 once and into 15 3 times. 3 goes into 3 once and into 9 3 times. I then like to multiply across the top and across the bottom just so I can combine stuff and rearrange stuff. I have a 3 times a 3, which is 9. And I have an s to the 4th, a t to the 2nd, and a u. On the bottom, 1 times 1, so I don't need that. If I put them in order, I have an r, an s to the 2nd, a t to the 5th, and a u to the 3rd. Again, you don't have to put them in order, but it looks nice when you try to rearrange them. Then I'm just going to...
why did you do that? Okay.
So everything lines up nice.
Oh, okay. I never thought of that one.
Because then I'm going to do some canceling, right? So I can take out 2 of my s's, which means I'm going to have an s to the 2nd on top. I can take out 2 of my t's, which leaves me a t to the 3rd on the bottom. And I can take out 1 of my u's, which leaves me a u to the 2nd on the bottom. So on the top, I have a 9s to the 2nd. On the bottom, I've got an r, a t to the 3rd, and a u to the 2nd. And that's going to be my answer then. Do I have to do this step? Probably not if I wanted to try to cancel in here, but it gets messy and people tend to leave things out, and that's why I like to rewrite it. I'm going to move the board so this is up a little higher for the next one. So number 5, we're going to rewrite this as a multiplication problem. So 7mn to the 2nd over 12x to the 3rd y times the reciprocal 3x to the 4th y to the 4th and 28n to the 4th. So we can do some reducing there, right? 7 goes into 7 once and into 28 4 times. 3 goes into 3 once and into 12 4 times. So on the top, I have an m, an n squared, an x to the 4, and a y to the 4. On the bottom, 4 times 4 is 16. And then I'm going to put the n to the 4th first, and then the x to the 3rd, and the y, just so they line up nice and neat. Then I'm going to do some canceling. I can cancel out 2 of my n's, which means I have an n to the 2nd down on the bottom. I can cancel out 3 of my x's, which means I just have a plain x up on top. And I can cancel out 1 of my y's, y to the 3rd. So on the top, I have an m, I have an x, I have a y to the 3rd. On the bottom, I have a 16 and an n to the 2nd power.
A 16?
Yep. 4 times 4, right?
Oh, you multiply them on the bottom? I was...
They're on the bottom, aren't they?
Okay, yeah.
Because on the tops I just had 1s. On the bottoms I had 4 times 4. So that's 16 down there on the bottom. All right, try number 6. All right, so I flip my second fraction around. I'm going to multiply. I'm going to say, okay, first of all, 3 goes into here once, into here 3 times. 5 goes into here once, and into 10 2 times. So when I multiplied, 3 times 2 is 6. I have an n to the 5th, a p squared, and a q. On the bottom, I have 1 times 1. I don't really need that. Putting them in order, I'm going to do the mn squared first, and then the p to the 4th q squared. Then doing my reducing. I can take out 2 of my n's, which means I have an n to the 3rd. I can take out 2 of my p's, which means I have a p to the 2nd down on the bottom. And I can only take out 1 of my q's, which leaves me a q down on the bottom. So on the top, I have the 6 n to the 3rd. On the bottom, the m, the p squared, and the q. There's my answer. Most common thing I see people do is forget this variable that's all by itself that they didn't have to do any canceling with, and they kind of forget it's even there.